Hey, hello and welcome to the next part in this video where we're trying to compute how much how much carbon humans actually produce and how does that compare to what's already in the atmosphere in terms of carbon. So in the last video we found out that we are consuming the total world is consuming 86 million barrels of oil per day. We converted that to gallons and then we converted that to kilograms. So it's 8 billion kilograms of oil are consumed per day. So and then we talked a little bit about how most of the oil is typically some sort of um, carbon and hydrogen chain, of which most of that, one example is hexane, and most of that, and by weight, is carbon. 84% of hexane is the weight of carbon. Okay. So by the way, actually, one comment I want to make about that is when you burn something, like let's say like you burn hexane, you're going to get like C8, 8H18, and you're going to burn it. Burning, means you're interacting it with oxygen. That produces CO2. And I'm not going to balance this. I'm just going to tell you you're going to burn it. It'll produce CO2 and water. So the water is fine. It's just going to be water, which might be water vapor, or eventually, condense onto the ground. But this is what happens when you burn oil. You produce this gas, carbon dioxide. Di meaning the two. Okay, so going back to this number we had here. Actually, let me go back to yellow. So we have 8 times 10 to the 9 kilograms of oil per day. So 8 times 10 to the 9 kilograms of oil per day. If we multiply that by 0.84 carbons per unit of oil. So 84% of the oil is carbon. Well, that gives us roughly 7. And this is, approximate. 7 times 10 to the 9 kilograms of carbon. And by the way, all the carbon that's in there gets converted into carbon in the atmosphere. There's nowhere else for the carbon to go. The hydrogen all goes into water, but the oxygen that you react with, some of it goes to form the carbon dioxide, and some of it will react to form the water. But anyway, all of that oil that's burned will produce carbon, and will produce this much carbon per day. Okay, so now let's just say that that's like our current consumption. The Industrial Revolution, began on the order of 100 years ago. We didn't burn that nearly as much as that early on, but even for the last 50 years, we've been burning a lot, and we will continue for the next 50 years. So, in fact, even more as countries like India and China start to consume a lot more. So let's just take like 100 years, like maybe from 1950 to 2050. It's a slight, I agree this is going to be a slight overestimate, but let's just figure out how much carbon we might produce over that 100-year period. So we're going to have 7 times 10 to the 9 kilograms of carbon burnt per day times 365 days per 1 year times then we're just going to multiply by 100 years. Let's just say that, over a 100-year period, how much carbon might we put into the atmosphere? So notice that all these things cancel. Days cancel, years cancel. We're going to be just left with kilograms of carbon. So let's pull out our calculator. So we're going to have 7 times 365 times, and then times 100. So that's I'm going to round it to 2.6. That was 10 to the 5 times 10 to the 9. So that's 2.6 times 10 to the 14 kilograms of carbon. Wow, okay, that sounds like a lot, but that's how much we could put into the atmosphere over a 100-year period, just from burning stuff that's coming out of barrels of oil. It's not even including coal, it's not including natural gas and other things. Okay, so how does that compare to the atmosphere? So let's go back to Wikipedia and look up the atmosphere. So if we look on the atmosphere, if we look on this page, and the page you can look at is Earth's atmosphere on Wikipedia. You can just Google Earth composition atmosphere or even Earth mass. You'll see here the total mean mass of the atmosphere is 5.8. By the way, you don't have to worry about what this mean is. It's fluctuating due to water vapor, but it's 5.14 times 10 to the 18 kilograms. And we could actually go back and try to derive this. The circumference of the Earth is 25,000 miles, and the height of the atmosphere is somewhere between 50 and 100 miles, and the density is changing. But we could get an idea of what it is. But let's just take, Wikipedia's number is probably pretty good, and people have spent a lot of time figuring out exactly what it is. So, but if you want to, you can try to go calculate this. So it's 5.1 times 10 to the 18. So Earth's atmosphere is 5.1 times 10 to the 18 kilograms. Okay, so the next question is, well, how much of that is carbon dioxide? So actually on the same page, if you look here, it says composition. And it says 78% of the atmosphere is nitrogen, 20 to 21% is oxygen, and by the way, that's actually, this number changes somewhat as you go higher up. Or rather, the density is going to. I don't know if the actual composition changes that much. I assume it would a little bit, but the parts per million in volume will go down, and you know that's why you have trouble breathing as you get to higher and higher altitudes. Anyway, so it's and then the main question is, what's carbon? Well, carbon dioxide is 0.038%, and if you actually go to another page, click on this page on carbon dioxide Earth's atmosphere, you'll find what the composition is by, actually there's another page I found. They have that same number, 0.0383% by volume, or 5% by 0.0582% by weight. Okay, so if we did 0.0582% times this 5.1 times 10 to the 18 kilograms, well, what do we get? Clear this. So 0.0005, you have to remember if it's a percent, you have to have 2 extra zeros, 582, okay, times 5.1. So that's equal to, basically, I'm going to call that it's 0.003 times 10 to the 18. So that's equal to 3 times 10 to the 15 kilograms of carbon in the atmosphere. Interesting. Okay, so now, look, we just figured out what the total weight of carbon is in the atmosphere, and let's compare it to the amount that we could put into the atmosphere just from burning oil over a 100-year period. And by the way, remember, this is an estimate. This is kind of a rough estimate. It's actually pretty accurate. So if we divide that, so ratio of burn, so what's there to what we add. So this is CO2 added to what is there. If we just compare those ratios, that's like, actually this is almost 3. Well, let's just leave it at 2.6. This was 3 times 10 to the 14 over 10 to the 15. So what does that equal? So that this is actually almost 1, right? Let's just say it's like point. It's about point. What is that? So if multiplied by 3, it's about it's about 0.8 something. Let's actually say it's 0.8 because maybe we overestimated something. So it's 0.8 times 10 to the minus 1, so that's equal to 8%. So we could actually, just by burning oil, increase the amount of carbon in the atmosphere by 8%. So the point I'd like to make here is that we can, in fact, change the composition of the atmosphere. And this is only oil, so there's a lot of other things going in there. I'm going to have to stop there.